In this video, we will look into a very fundamental and a very important algorithm using competitive programming, which is known as binary search. Binary search, like linear search, is a searching algorithm wherein we're supposed to find the position of an element in a given array. However, in binary search, it is required that the array is sorted. So the array must be sorted. For example, in the array given over here, it is in increasing order and it is of size 11 whose index starting from 0 and ends at 10. Let us have a target element, say 13, whose index must be found. So the index of 13 in this array will be 7. So 7 will be returned using binary search. And if say 13 doesn't exist in the array, we can return something like -1. So now let's see how binary search works. To explain binary search, I will use this array as an example, and we need to find the position of the element 13 in this array. So in this algorithm, we always have a range which is specified wherein we will be searching for this element within that range. So the range over here will be the entire array at start. Now we take the middle element. So the middle element here will be 6. So 6 is our middle element. We can calculate the middle element by taking the lowermost index and add the highermost index in the range and divide it by 2. So it will be 0 plus 10 by 2, which is 5. At index 5 we have the middle element. So we compare a target element with our middle element. So we see that 13 is greater than 6. Since this array is sorted, we know that 13 will exist only in the right hand side of this array. 13 cannot exist on the left hand side of this element 6. So we update the range of a search to the right hand side part. So now our search range will be reduced to the right half of the original range. Originally we had from 0 to 10. Now we will be having from 6 to 10. We have eliminated all elements on the left of the mid element, including the mid element. Now we have to calculate a new mid element, which will be 19. You can calculate it otherwise using a lower index, which is 6, plus a higher index, which is 10 by 2. This will be 8. So our mid now is 19. Now we can see that our element 13 is less than 19. So 13 must exist on the left hand side of a range and it can never exist on the right hand side. So again we update our range to the left hand side part, not including the mid. So our range will now be this. So we keep doing this process until we get our mid element as equal to the target element. Now our mid will be 6 plus 7 by 2, lower index plus higher index by 2, and by taking floor of it we get it as 6. So our mid element will now be 9 and 13 will be greater than 9. So we will again reduce our range to only 7. So our range is now the only element which is over here, and our mid is automatically 13. So 13 is equal to 13. So therefore our element target has been found and its index is 7. So in a nutshell, what we are basically doing is, in every iteration we compare the mid element of a current range with the target element. If the mid element is greater than the target element, then we reduced our search space to left half. If our mid element is less than our target element, then we reduce our search space to the right half. And if mid element is equal to our target element, then our element has been found. Unlike linear search, whose time complexity is O of n, binary search has a time complexity of O of log of n base 2. This is because in every iteration we are reducing a search space into half for every iteration. So now that we have understood how binary search works, let's see how the code looks for it. Let us assume that the array given is A, whose size is n, and the element to be searched for is x. In this algorithm, we will initialize two variables called left and right. So left will correspond to the leftmost index in our current search range, which will be the first element in our array at index 0. So left will be equal to 0. And we will have another variable called right, which will be the rightmost index in a current search array, so which will be 10. So in this case, right will be equal to n minus 1. So basically left and right will denote a current search space where we will be searching our element x for, and initially it will be the entire array. Now we will run a while loop where left must be less than equal to right. This condition will be invalid when left is greater than right, which also means that there is no valid range existing, as left cannot be greater than right, and that a target element is not found. So if left becomes greater than right, it means that x is not found in our array. So now inside this loop, in every iteration, we will calculate our middle element. So mid will be equal to left plus right by 2. So mid is the index at the middle specified by the range left and right. Now we need to compare a target element with our middle element. So we do if a of mid is equal to x. So if our middle element is already equal to the target element, then we return mid. Else, if a of mid, if the middle element is less than x. Now we know that x must be in the right hand side of the range specified by left and right. So we must update left to be equal to mid plus 1. So in our original case, our x was 13 and our middle element was 6. 13 was greater than the middle element, which is satisfying this condition. So we will update our left, which is 0, to the middle element plus 1. 5 plus 1, 6. So next time our left will be pointing over here and right will not change. So our range will be this for the next iteration. Similarly, if a of mid becomes greater than x, which will fall in else condition, we will update our right element to be equal to mid minus 1. So over here we will know that we have to reduce our range to the left hand side. So we will not touch the left variable. Instead we will move the right variable to one position prior to mid. And so finally after the while loop we return minus 1, since if the element was found, it is already returned over here. So this is the code for binary search. So there it is, guys, an introduction to binary search. If you've liked it, please hit the like button, share it among your friends, and subscribe to this channel.